In this video, we're going to look at using right angle trigonometry to solve angle of elevation and angle of depression problems. And before we do this, we want to talk about what do we mean when we say angle of elevation or angle of depression. So let's suppose that you are at some point above ground level. So we'll make this at some point P. And off in the distance you look down and you see some object at point A, and you look up, and at the top of a building somewhere over here at point B, you see something at the top of a building. So I'm going to draw a line perpendicular to the ground there, from B perpendicular to the ground, and we assume that you are located at some point P above the ground, where that is also a right angle. So angle of elevation, angle of depression, when you're looking at an object, you identify those angles by establishing a line through your viewpoint. So if we're viewing things from this point P, we establish a horizontal line through that viewpoint, a horizontal line that is parallel to the ground. And if we're looking from P down to A, this angle here, this acute angle, formed by the horizontal line through your viewing position that is parallel to the ground. This angle theta is the angle of depression. Depressed because you're having to look down, or you're having to depress your view downwards to be able to see the object. Whereas if you're looking up, the acute angle that you form along your line of sight with B and the parallel line that is parallel to the ground, this angle phi is the angle of elevation. Both of these angles are measured using a horizontal line through the viewing position, based on your line of sight to the object that you're viewing. So these are your lines of sight. So a typical application problem: we have a 6-foot tall person standing 100 feet from the center of the base of the Space Needle in Seattle. The angle of elevation to the top of the needle is about 80.522 degrees. How tall is the Space Needle? So step one in angle of elevation, angle of depression problems is to draw a picture of the situation. So you have a person who is 6 foot tall standing on the ground. Here he is. My person, we don't make him look fancy like a person. A stick is perfect. This is a 90-degree angle, and we know that this distance here is 6 feet, and this person is looking up towards the top of the Space Needle, and we're going to assume that the Space Needle makes an angle of 90 degrees with the ground. Now, through your viewing perspective, at point P, draw the line that is horizontal to the ground. And this horizontal line is going to intersect the Space Needle center at some point right here. And we're going to let the distance between the top of the needle and that intersection be h. We're going to let this entire distance, the height of the Space Needle, be n. And then we're told that we have an angle of elevation when we look up at the Space Needle along our line of sight of 80.522 degrees. That is this acute angle right here, 80.522 degrees. And so what we want to recognize is that the total height of the Space Needle is going to be this height h. That is from the top of the Space Needle to the intersection between the Space Needle and the horizontal line through the viewing position. So it's going to be h plus the extra 6 feet. That is the height of the person. And then my viewing angle here, my angle of elevation, I want to note that h is the height of the side opposite this right triangle right here. H is the side opposite the viewing angle, and I'm told that between the person and the base, the center of the base of the Space Needle, that this distance is 100 feet. which also means from here to the Space Needle is also 100 feet. So I have an angle, I have the side, I want to know the side opposite that angle, I know the side adjacent that angle, so I'm going to use the tangent function. I'm going to say that the tangent of 80.522 degrees is equal to h, which is the side opposite the tangent function, divided by the 100 feet that is adjacent to the 80-degree angle, so divided by 100. I multiply both sides by 100 to isolate h. Now I know that 100 times the tangent of 80.522 degrees is equal to h, which means that the height of the Space Needle is h, which is h. Needle height is h, which is 100 tan 80.522 degrees, plus the extra 6 feet, that's the height of the person. And then I can approximate this using my calculator. This is approximately equal to, so we'll kick out to the calculator, we'll keep that. Kick over to the calculator. And we're going to do 100. Let's make sure we're in the right mode first. We are in degree mode, so that's good. My angle is measured in degrees. So back out to the screen. So I'm going to do 100 times the tangent. 100 times the tangent of the 80.522 degree angle plus that extra 6 feet. Enter. And we get about 605 here, 604.9, so 605 feet as a good approximation. So we'll kick that in as our approximation, 605 feet. And then if you are being wise, you actually at this point Google the height of the Space Needle. There it is, and it's 605 feet, so your answer makes sense. So that's your check on work when you don't have an answer key. So we'll do one more example. We'll still use the Space Needle. So we have a person standing near the top of the Space Needle. Notice there's a car wreck some distance from the Space Needle. If the angle of depression from the person's eyes to the wreck is 32 degrees, how far away is the accident from the base of the Space Needle? So again, draw a picture first. Here's the ground. Here's the Space Needle. We assume the Space Needle makes a 90-degree angle with the ground. Hi, I'm the Space Needle N. A person standing up near the top, they look down towards a wreck. The wreck is at some distance from the base, center of the base of the Space Needle. We'll call that distance W to go with the wreck. The height of the Space Needle we already know. We calculated that to be 605 feet on the previous slide. Now put the horizontal line in through your viewpoint, the horizontal line, horizontal with or parallel line parallel to the ground, horizontal line that is parallel to the ground. And we're told that the angle of depression, that's the acute angle formed by the horizontal line at your viewing height with the line of sight. We're told that angle is 32 degrees. And what I want to recognize here is that this line of sight transverses these two parallel lines. So we have a transversal cutting parallel lines. So we have the alternate interior angles must be the same. And I know the height opposite that 605, I know that the height opposite 32 degrees is 605, and I want to know the length of the side that is adjacent the 32 degrees. So this is an opposite over adjacent situation. So again, I'm going to use the tangent function. I'm going to say the tangent of the 32 degree angle is opposite the 32 degree angle is a 605 foot height. And I would really like to know this length or distance that is adjacent to 32 degree angle. I'm using the tangent function, not the cotangent function in this case. The cotangent function would work. I could say cotangent of 32 degrees is cotangent is adjacent over opposite. And there's a sense in which this is nice because the unknown is now in a numerator position, but the calculator doesn't have a key to directly use the cotangent, so I might as well use the tangent function. And then we just need to get w isolated, so we're going to multiply both sides by w. We'll get w times the tangent of 32 degrees, and then we divide both sides by the tangent of 32 degrees. That equals 1, so we get 1w by itself equals 605 divided by the tangent of 32 degrees. And then if we want to approximate that distance, we go to the calculator. We'll keep that. We go to the calculator. Should still be in degree mode. Yep, still in degree mode. Second, quit. And we're going to take the 605 and divide that by the tangent of the 32 degrees, and that's going to be about 968 feet. So the distance from the base of the Space Needle to the wreck is about 698 feet? My brain's already forgetting what it saw. 698 feet. Check that one more time before I close the 968 feet before I close the video. So I got those two numbers backwards. 900, that's terrible, isn't it? 968 feet. So cross it out. It's about 968 feet, and life is good.